intro video after all. Hey Tim, how you doing?
Everyone? Just fine. How are you?
Doing all right. How are things in the Netherlands? Is that not one but multiple different little Java Dukes in your window?
Yep. Yeah. That's like the one is like the Lego Azul thing, and
Yeah,
then
yeah,
this
the
is like
Azul.
construct yourself.
Yeah, if
Finally
you ever
ran
see
one before they ran out.
which is the other one?
The other one is I got this from the Java bin, like the Norwegian Java user group. This
Nice.
is like a Viking Duke. Yeah.
That's very cute. I like that one. Yeah, if you ever see
And
the
yeah.
Azul booth at a conference, they tend to have these little Lego Dukes as party favors to give out. So if you don't want of your own, check out the Azul booth at probably any conference, and they'll have it.
Yep. There's even like a third one, which is like a mug that I got from the Java user group Paderborn. What is
Oh,
that?
that's nice. I like the coat of arms. At the coat of arms for the city that the
Yep.
user group is in.
Yep. So just just a small little like Java tidlets on a windowsill. Yeah.
Nice, nice. So, all right. So now I know what to get you for Christmas. A new Duke to expand your collection. I know you have bare shelf space on the wall behind you that could be filled with
Oh, okay.
tchotchkes.
I know, Peter, our colleague, he has his snowboard in the background of his Zoom calls. I don't know,
Nice.
maybe something for the future. But for now, it's still like on some chairs because I haven't found the time to put it away yet. So,
Yeah, yeah, yeah.
yeah. Oh well.
Well, right on. Let's
Yeah,
get into the news.
yeah, sure. So as always, I will share a couple times. Starting with this one. So as you know, we had our Code Remix Summit in May, and that has been a welcome source for us to highlight some content that was presented there. And we're doing so this week in particular through both a blog and a couple of different videos that we've put online just yesterday. So if you want to see a bit of what was presented there, then we have a blog here highlighting or summarizing some 5 different talks that we did that were presented there. The first one on AI-generated tests from our friends at DivBlue, of course. The second one is on observability and understanding from Mohammed at Spotify. And I believe we'll have him on in the near future as well. So that's if you want to read a small bit of what he went into, then that's on the blog as well. And then code cleanup at scale for productivity from Pratik Patel. So that's interesting as well. And then here we have on AI without trust. I believe we have a matching video as well for some of these. And then here a new model for developer productivity. So if you are not the one to read too much, then we have the matching videos as well. So here there's one from our very own Kevin Brockhoff on daily vulnerability mediation in sprawling Fortune 50 enterprise. So that one is available on YouTube. If you're already watching us there, then just click on the videos in the playlist that we have available. And then the next one is from our friends at Snick, a practical guide to AI threads presented by not Brian Vermeer, but their other Brian, I can say. So that's up. DivBlue, again, Andy Piper presenting on how to generate tests for maybe ahead of some migrations that you're planning. And then the last one's this one from Ben Lloyd Pearson. Are you prepared for the AI revolution? This one, like I said, is from Pratik Patel, matched up with the blog that we put out as well. Architect's Guide to Managing Your Code Base. And then finally, Mohammed, continuous profiling, which I think we're going to highlight on a future call. So all of that is available for you to read and watch. And I hope you enjoyed it as much as we saw it live in Miami just 6 weeks ago, I think. So yeah, that's all good. So that's it in terms of updates that I have for you this week. So yeah.
Although I will throw
So
in a
with
little
that,
bonus
yeah,
update, not necessarily from us,
yeah,
but
yeah,
all the Java ecosystem's friends over at Sonatype, where they have changed their
yeah.
snapshot repository over, which affects where the whole ecosystem of open source publishes their snapshots to, including us. So if you're resolving those snapshots, I should probably have pulled up an article or something, but go look up Sonatype's news if you're using snapshot builds of OpenReact recipes or anything else. Is you may have to change. You will have to change the URL you are resolving them from to continue to get snapshots.
Yeah, absolutely. So the thing they've sunset is the publishing of new snapshot versions, but it's
Right.
still available for you to resolve those versions. So if you don't do anything, soon enough you'll only see outdated versions of snapshots coming in,
Although I
which
think
can
they
get a
have
bit
like a
confusing.
90-day cleanup, so those will presumably also be gradually disappearing.
In that case, I think we'll see some folks only chime in 3 months from now. They haven't
Very
had any
likely.
updates.
And when those
But
folks chime in,
yeah,
we'll know they didn't watch Code Remix, and we'll refuse to help them on those grounds.
it's just we of course have been making these changes with a lot of like bulk pull requests being sent out, and we should be mostly covered there.
Yeah,
But of course, as
maybe we
always,
should whip
yeah,
up a quick recipe to just change URLs and Maven Palms and build.gradle files. That takes like seconds, right? Not even like a
I
minute at
believe
most.
we've done
We could
it.
probably
We've
just do a
just not
textual find
shared
and
it.
replace.
Let me try to find the one. So this is gonna be very like off script. Open rewrite.
Yeah, unlike our normally very tightly scripted presentations.
As folks know the show like this, we value high production quality. So
Absolutely.
here we have the Modern Marketplace, and what we're looking for is the Open Rewrite org, which I've selected. Then we're going to go to recent activities, which is
Right
here.
there, yeah.
And then we did the Sonatype update recipe today. So in this case, we, like I said, created 37 pull requests just from this run. You've seen some of them were
Why
cancelled,
don't we show the
completed,
results from
merged,
one of these,
blocked.
since I didn't know the URL to tell the good people off the top of my head, and it would
Yeah, sure.
surely be in the recipe result.
So here you have a link to the results. And then this is the changes that we had to make.
I
So
still just
we
see
were
the
swapping out.
view.
And so here's the changes that we had to make on one of our repositories, just swapping out the credentials because we needed new publishing credentials, even though the URLs were changed in a different location. I think we had a couple more examples on maybe Open Rewrite itself.
Likely.
Trying to find that.
So this recipe would have updated the URL if the URL was present anywhere.
Absolutely.
Yeah, I think we
It's just,
mostly have the URL inside one of the build plugins, so it's not
yeah.
in the repository
I would have
itself.
sworn. I would have sworn we had some dedicated commits here as well. It's just I wanted to instead show you the recipe. So for that, we have to go to the recipe results and click on rerun. And this is the Sonatype update recipe that we have. So it's a couple of change key and then find and replace that we're doing. And then finally, those find and replace for those URLs. So if you want to see what that looks like in YAML, it is just this. And we can
Well, I think I
post this into.
would probably change that final find and replace to always be HTTPS rather than keeping it HTTP, because why wouldn't you switch to the more secure URL? So yeah, anyone who wants to update their Sonatype URLs for the snapshots repository, feel free, enjoy. You're welcome.
So the recipe is there. Join me through our open source Slack if you want to get this exact recipe, or find it through the builder link that we have here.
Or pause the video on this frame and just type it out.
It's only 10 or so characters, I think, the unique ID. So
Yeah.
should be fine.
Anyway, so with those with that bonus announcement done, that brings us to this week's guest, the venerable and respected and widely known Shannon Pamperl, Gradle expert extraordinaire, who is here with us today to share some tips about build performance. Isn't that welcome to the show, Shannon?
Thanks for having me back.
How you doing, buddy?
Oh, not too bad. How about yourself?
Doing all right. I'm gonna take a long weekend. Since my birthday is around the 4th of July, so to just combine those into an extended holiday for myself. So I'm doing good.
Yeah, that would be nice.
How about yourself? Do you have any fun plans for the weekend?
Probably just hang out with some family. But
Classic.
4th of July here, and all that fun stuff for the States. So, but beyond that, probably not a whole lot.
Fair enough. Well, that could be nice in its own way.
Yeah.
So Gradle, people complain about it. People like, my Gradle build is bad. Gradle sucks. I prefer Maven, and other such statements. How do you? Are those people wrong, Shannon? Are they wrong and also bad and stupid?
I don't necessarily think that it's wrong, bad, or stupid. But
well, that's good. I set you up with a very provocative intro, but you're much too nice a guy to take the bait. So, kudos.
But what I will say is that regardless of what build tool you have, over time you'll acquire cruft,
for sure,
regardless of which one it is. Now, some are easier to acquire cruft than others. Gradle, with its imperative build logic, is certainly one of them.
Mm-hmm. It's great for constructing foot guns to.
Yeah. It gives all your colleagues all the flexibility.
Yeah. The Groovy plugin in Maven is a whole nother one where you can construct a foot gun forward, but and you try to avoid those things.
You try, and it could be a challenge when a well-intentioned coworker solves a real problem in a way that messes up the build downstream, and you're like, it's checked in and it works, and fixing it is going to be really, well, it works superficially, but might cause performance problems of various kinds that I'm sure we'll get into, or other issues with idempotence or correctness of the build, and now I have to figure out how to untangle this.
Yeah, trying to get back to a state where, well, it was working. It looks weird, but now it's not working, and it doesn't look quite right. So let's diff the two. Yeah, those are always fun. That feels like my journey with rewrite JavaScript recently.
Oh, I bet. How's that been treating you? What have you been doing with rewrite JavaScript?
Oh, yeah, as part of the recent changes, it was, I noticed that the open rewrite main rewrite build was taking like 2.5 minutes to configure. And,
that is long. That's a long time.
Yeah. Well, and when you think about it in an IDE as well.
And for anyone who is not intimately familiar with the steps of the Gradle build lifecycle, the configuration phase is what sets up the task-directed graph. So it precedes any actual action being taken. So you type Gradle build or something else, and it sits there for a while before you actually see it hitting compile or assembling a jar. That's the configuration phase, where it's running all the code in your build scripts and in all of the plugins you've applied. And if any of that code is slow or expensive, well, that's just overhead on every single invocation of any Gradle command within that build.
Well, and it's even more than just any Gradle command, but anytime you want to get information from Gradle as well.
True.
So like IntelliJ uses the tooling API to pull out models of your Gradle build, whether it's the tasks that are involved, the dependencies, the project layout, all of those things. And you have to hit the configuration phase to its entirety every time you access the project. Well, if you do that a couple of times, maybe example, opening up a repo for the first time on a day, like you just invest time in waiting for the IDE to finally catch up so you can actually start writing code.
Mm-hmm.
That was the story of my life one morning when I was like, okay, rewrite is taking way too long. I've waited 10 minutes now. Like, I just wanted to write a quick change.
10 minutes.
I'm like, okay, this is enough. Let's fix this. And that became the start of this story.
Mm-hmm.
And, how can we optimize the rewrite build back to being more efficient? It's
Sure.
not as efficient as it could be yet. There's still
Sure.
way more that we can do.
Sure.
But can we buy some of that time back?
So what are the first kind of steps you take when you're looking at a build and being like, this is slow and bad. I would like to make it better. Do you reach for a build scan or other instrumentation, or do you just know a few common anti-patterns to look for?
So it's kind of a little bit of both. So Gradle build scans, especially with Velocity, make this significantly easier now
Yes.
than it was prior to Velocity Gradle Enterprise existing. Before, you would have to go through and try to tease that out, looking at the old patterns and trying to figure out, like, where am I spending time?
Mm-hmm.
Now it's a lot more straightforward because Gradle Enterprise can just tell you, or rather, Velocity can tell you.
Right.
I've used both. It's still getting used to the term change.
Yeah. I thought the name change was a little confusing, but I understand why they did it because Gradle Enterprise supports like Maven and Bazel and probably another build tool by now. But they'd go in and try to sell that to a Maven shop who could potentially actually benefit quite a bit from the build caching. And so
Yep.
there's also the build scans. They'd be like, "We don't have Gradle. Why are you here? Why are you talking to us?" They're like, "No, it supports Maven. We swear." They're like, "But it's called Gradle Enterprise. Like, I don't believe you." So I get why they changed the name.
Yeah, and recently, SBT has official support, and then Node and Python have beta support.
Really trying to cover all the bases. Smart.
Yeah. It's definitely going, but it definitely makes it a lot easier to dive into that. And I'll go ahead and screen share really quick.
Yeah,
Hopefully
please do.
this works right. Come on. That one. All right. So Gradle has a really great repo out here for some validation scripts, which go way above and beyond what I started as part of this journey.
Mm-hmm.
But one of the first things that you kind of do is when you're optimizing a Gradle build is you want to run a task that doesn't cause other tasks to be created. And you want to identify those that don't, those tasks that are created eagerly or by accident, and try to avoid that using things like tasks.register, with type configure each, these kinds of small idiomatic patterns.
Mm-hmm.
But then you get into much larger ones about how do you ensure that build cache entries are actually persisted? If you change the directory, if you have different file encodings, these little gotchas that become really a part of Gradle best practices and identifying those. So I've done a bunch of build scans, but I had Tim run one today to kind of help illustrate this in particular. So if we go,
can we zoom in the browser window just a little bit?
Yeah, absolutely. Better?
Excellent. Very legible.
All right. So we go in here, we can look at the performance tab, and we can actually look at the configuration phase, and we can see right off the bat how many tasks were eagerly created, even though we ran the help command, which should have created 0.
Right.
Yeah.
And then we can dive into where those were created. So here's a really suspicious one.
The license plugin, everyone's favorite.
Yeah. everyone's favorite license plugin. Well, if you
I
dive
think
into this a
that's
little further,
last. I think it's last had a release at least 4 years ago, maybe 8.
yeah,
We should just replace that plugin with the recipe of the same functionality already. We already have that recipe we run on pull request, right? We could just make that part of make the license header part of recipe part of that,
yep,
and just that build plugin entirely.
yeah, and you cut out 150-ish plus tasks being created.
Yep, yep.
Not a whole lot of time being
No,
consumed, but I mean, it all adds up. And
yeah,
anything you can do to avoid it is all benefit, right?
right.
So, like, this is kind of one step of the equation, and we can kind of see the outcome here of like the first phase was like, okay, hey, we're using some
And a
with
little bit too.
Yep. Sorry. So like we were using some with types. Those are eager. Okay, let's just tack on a configure each. And like right now, these don't have open rewrite recipes for them, but they're very easy to identify.
It's true.
Add a rewrite for it. So, definitely something that can be added as best practices. And then now,
To be clear to anyone who would wonder what the difference there is without the configure each, it is going to eagerly, immediately when the line of code is encountered during the configuration phase, go and all of the tasks of that type. It's going to go run the code in that block on them right then and there, even if those tasks are not later going to actually be scheduled for execution. So you could spend time configuring something that you don't actually run. But if you use configure each, then the closure is just attached to, or the lambda, whatever you want to call it, is just stuck in a list. And then when it's time to actually run the task, then the configuration is applied to it at the last minute. And one of the things about this kind of like lazy evaluation pattern is that it's very easy to, if you eagerly resolve one thing, you can end up eagerly resolving a bunch of things along with it. So you kind of have to be lazy about everything everywhere in order to avoid eager configuration costs.
What? Yeah, there was one in here somewhere. I'm trying to find it. But like one place where we use like .get on a task.
Yeah,
probably
grabbing a jar task.
Yeah, here. Oh, that's not provider. Never mind. But you get the idea. Like, it can be something like a with type that's eager, a get, any number of these things. And then now suddenly the build is a little bit slower, or at least the configuration phase is a little bit slower. And, as these little increments just keep adding up and adding up and adding up, you end up with just wait time while you're waiting for the tasks to get ready, for Gradle to get ready, before it actually even starts doing any useful work.
And I think we saw this most, alarmingly when I believe it was the npm pack, what the .get was called, and that meant that any unrelated build would also do that npm pack, which of course adds quite a bit of time to get you up to those 10 minutes of waiting before you can do anything else, even when you're not working on the JavaScript side.
And it's even like, I mentioned earlier that it was like 2.5 minutes, but if IntelliJ has to reach out 5 times, well, now you're suddenly at, a 10-minute range if they're all sequential. Most of the time, those kinds of things are, just because otherwise it's complex to get the results merged back together. And it just adds up. But you get into other things in the realm of how to improve builds, build cache, configuration cache. I mean, these are all mechanisms to help improve the execution time, build caches, and the configuration cache is store the configure phase from a previous run so you don't have to do it in future runs. as long as all the inputs are the same.
Yeah, that is it's tricky to get to the point where you can enable configuration caching in non-trivial builds, particularly with a rich ecosystem of plugins out there, many of which were written before configuration caching was a thing, including ours. Uh, oh, hey, it's Tim's mouse.
Guest appearance.
And I only pressed the mute button, so that's weird. But
Interesting. Like, is there a second camera, or was that is it the same camera that was just really interested in zooming in on your hand?
no, it's a second camera. I can try it again. Yeah, now it's muting again.
Interesting. Yeah, I've many times in the past, had like a where is it? I had like a PlayStation controller plugged into my PC from the previous evening's gaming, and gotten on a call, and everyone's being like, "Why is your voice muffled and also sounds terrible?" And I'm like, "Are you sick? What the hell's wrong with you?" And it's like, "Oh, the tiny awful microphone built into this controller. My PC was like, oh, you want to use this now, not the headset, not the webcam. You want to use this as your microphone." I've had I had a similar thing in the past when I used VR for gaming a little bit more. That the HTC Vive VR headset that I had has a little camera on the front, so that while you've got your bulky monstrosity on your face, if you want to see the world around you, it could show you that image. Or it could decide that this is the webcam you want to use, even though it's sat on the corner of the desk, pointing at a wall, and isn't the actual webcam. Anyway, a profusion of devices and helpful defaults. So Shannon, with there are other. You mentioned tools for measuring and improving build performance. Have you ever used the Gradle profiler before to analyze the performance of a plugin or build task?
I actually have, and I contributed to it way back when.
Really? You were a contributor to that project. I guess now that you mention it, I think I contributed a bug fix for it running on Windows at one point.
Yeah,
it's been a while though.
They used to only support the Oracle JDK for Java 8.
Mm-hmm.
And the JDK profile events were renamed between Oracle and OpenJDK. So there were two different event names.
I see.
So I did some contributions there to update the mapping such that it could work with OpenJDK based builds.
Nice.
Eclipse Tamarind.
Nice.
Or Yapium is another name.
Yeah, that's very helpful since mostly try to avoid using Oracle JDKs most of the time, and since there are cheaper alternatives out there.
Yeah, for sure.
Yeah. So I wonder, what advice do you have for someone who's like not a Gradle expert already, but is stuck with a Gradle build or Gradle builds that are bad, right? I don't know, because maybe you could track down your organization's Gradle expert if you have one, but maybe that person doesn't exist, and you're maybe interested in solving this problem for yourself or for your colleagues. Where are some things people can get started with in learning how to improve their build performance?
Yeah, there's that repo at the beginning that I had shared.
The dev velocity validation steps repo. Yeah,
those don't actually require dev velocity at all. It makes it more useful when dev velocity is present.
Right.
But they do output some of the same information, so that you can get some helpful parts even from an OSS build.
Right. And do those scripts work with, because Gradle still has the public, like, what is it, still scans.gradle.org, is that right?
Yeah, and you can always use public scans, Gradle.org as well. You just have to accept the license terms.
You have to accept the license terms. So yeah, just to be clear, it's a public dev velocity instance that Gradle runs for the benefit of the open source community / marketing purposes, which will which allows you to publish a build scan even without your own dev velocity server. Now you just have to accept that you're sending telemetry from your build to a third-party service, which is not indexed. It's not easy for a random person to just browse through the list of builds and see who's building what. But if someone had the URL, then they could get to your build scan. So in high security environments, even though there isn't really that much interesting or proprietary information in a build other than like the names of your Gradle projects, that may be too sensitive for the security policies in your in your area. But it is available for anyone to use, and Gradle would surely be happy to have your email address to contact you later with with offers.
For sure. But yeah.
So let's see. So we've kind of covered. So we've got the situation with the license plugin, right? That Hieronymus license plugin, which is creating 150 tasks. There's not really anything we can do aside from creating a new plugin or finding an alternative that is more performant, or making a fork or something there. Yeah.
Yeah. I mean, you're really at that project in particular, like Tim said, it hasn't had a release for like 4 or 5 years at this point. The original plugin author isn't responding to issues or pull requests.
Sure.
I mean, for all intents and purposes, the repo is dead.
Yeah.
Right? So at that point, like in any open source dead project that we use, your options are either fork it and maintain it yourself, find a replacement, or find an alternative that isn't a direct replacement.
Right.
And I think that's what we have here. And thankfully enough, there is a recipe in Open Rewrite for
applying license headers. Yeah.
Applying this, and some of the great work that Tim's done in the past for patch comments.
Yes.
So we can get the same functionality wise on the PRs, but not have to take the penalty of slow builds.
Right, absolutely. So let's see. Are there any performance-related tips that we should discuss with relationship to dependency management? I mean, Gradle's pretty good about caching, dependency resolution results locally. I mean, you do take a hit for using dynamic dependency versions the way that we often like to do in the Open Rewrite project, forcing it to, if you depend on a fixed version number and that version number has already been downloaded and it's not a snapshot, obviously no further checks of remote repositories are required. But if you depend on a dynamic version like a latest.release or a 1.plus or what have you, then Gradle has to go recheck that periodically to see if new versions are available. So avoiding dynamic dependency versions can improve the dependency resolution part of build performance a bit.
And it's even both, because the default on both dynamic and changing is 24 hours. But often Rewrite,
we in our build set that lower to 0, I believe. So it's on every indication. Yeah.
So every time you want to configure, it's, hey, refresh dependencies. You want to do a build, refresh dependencies. And you're always getting the latest, even though theoretically the world is not changing that rapidly.
It is convenient in local development scenarios where it might publish snapshots from one repository locally and then immediately want to use those in another repository. Now you might rightly counter, well, you could use Gradle composite builds for that kind of thing, which can be a viable alternative. I've always found that IntelliJ's support for that has been a little bit janky. Like whenever I've tried to use that in the past, I've run into problems with it sooner or later, and ended up, and I don't even have a specific example off the top of my head because I just got used to not doing it that way. But yeah, you could create a composite build, which is a way of linking multiple separate Gradle builds together in such a way that it would know to, if one depended on the published artifact from the other, it would know to substitute, the local build artifacts rather than using the published artifacts. Do you use composite builds much?
We do actually.
Yeah.
It all depends on how you want to construct things.
Hmm.
To your point, binary integrations are definitely the easy way to connect dependencies. Meaning, hey, I created a jar, I consume a jar in another project
Hmm.
via the published repo.
Hmm. Hmm.
But composite builds let you, use a local variant and tell Gradle to, hey, actually execute the tasks of my dependent build
Hmm.
anytime you want said jar. Just go do it. And that's convenient. We've got a couple of team members over here at Shelter that use it for 20 million line code bases,
It's a
and
couple
it's
lines.
really
It's a few lines.
reliable. Um, Now, I do agree. Historically, it was a little. Sometimes it works, sometimes it breaks. But I think now, like a lot of those kinds of things have been ironed out, so there's a lot more stable. So you may try it again,
Hmm.
but that doesn't discount, real time binary integrations. Like, they're still useful. There's still a means and a purpose for them.
Hmm. Hmm.
Yeah,
Yeah,
might be something
absolutely.
to look into and then document, because it is quite common that you have something to change in like open rewrite, and then have to pick it
Mm-hmm.
up in I don't know, migrate Java or Java dependencies
Yep.
kind of things. So
Yeah, for sure.
Yeah, I suppose while we're here, I could show a little bit of Gradle plugin authoring that I did recently for making a jar packed in a particular way, and there's of course many different ways one can write a Gradle plugin, but I will go ahead and share my screen and maybe get a live code review from Shannon. Although I don't expect that this will be particularly controversial with him. Anything I've done is I think I've followed best practices reasonably well here. But so recently I was writing a build plugin that would take a jar and do some stuff to it, right? It would change around the contents, put it in a particular layout, and I made a very basic like Gradle task type for this. And this is, I happen to only need this in a single repository, so I put it in the build source directory, which is like a build that precedes the rest of the build to provide tasks and types and plugins that can be used within that build. And this task can be configured with a number of different properties. Like it's going to take in a jar and a classifier that you want the new jar to have, and the location that you want to write the modified jar to, which should be different than the jar you take in. Like here's a best practice for you right now if you're ever doing Gradle build plugin authoring: never modify a file in place. Always like create a new file with your modifications to it,
Mm-hmm.
because the basis of Gradle's performance, the basis of having good performance, is work avoidance, which is based upon checking that every task is idempotent and exclusively owns its outputs. This is to say, when Gradle goes to run a task, it's like, okay, this task has three inputs: this injar, this classifier string, this and this, or two inputs and an output. And so it's going to say, okay, last time I ran the build, the inputs had this hash and the output had this hash. Have those changed? No, then I can skip running this task. And that's also very similar to, or also the basis for using build caching. So having an exclusively owning the output and never modifying an input in place. Because if I did modify it, like I could have written this task to take this in jar and to modify it directly where it stood, but then in the very next Gradle build I ran, well, then the task that produces that jar would be like, oh, I'm out of date. This jar has changed since I produced it, and so it would make a new jar, and then it would come to this task, and it would be like, well, now my inputs have changed since I last ran them.
Mm-hmm.
So that would, in one step, guarantee that those tasks were never ever up to date and would always have to execute and could never be skipped um, when you ran them. And then the kind of the other thing I did was use these provider types, which is part of Gradle's API for making lazily configured or lazily configurable tasks, where you can provide configuration to them without having to um, without having to like eagerly realize the other task you're getting that configuration from, and can automatically wire up dependencies between tasks, so you don't have to explicitly say, this task depends on that task. If you're, filling in a provider with a provider from another task, it'll just know to wire that up for you. And then finally, for convenience, I put on a configuration method here that, and I had a variant that accepted a jar task that it could, eagerly get the configuration it wanted from. If you already have a fully realized jar task, then, fine to do that. But we can also take a task provider of jar, which is to say a lazily evaluated jar task that hasn't been turned into a real task yet. And with providers, you can use, things like flat map in order to get the configuration in a way that is not, that this code in here is not actually going to be run until something has to go and evaluate this parameter, which it won't have to do until the task is actually going to be executing. So, what do you think, Shannon? Did I get that mostly right? Is there anything I should improve here?
Well, I've spotted at least 3 things.
Great. What are the 3 things?
So the first one is your input file.
Yeah.
Actually could use with a path sensitivity relative. What this means is
is that a different
path sensitivity dot relative.
Oops. And what is that doing for me?
Yep. So what happens is this helps with build cache or cacheable tasks in particular, which can't quite tell if this is a cacheable task yet because it's one line above where your public class is. Scroll up. So there's another one.
Default.
You could make this a cacheable task.
Potentially, I thought about that, and like Gradle, like this is a task that takes a jar and modifies its content, and it's a fat jar specifically, so it's going to be large, right? Like 100 megabytes potentially. And I know that Gradle themselves decided not to make the default jar task cacheable, as just the size involved meant that it was often more expensive to like download that jar from a remote cache than to recompute it. At least that's my understanding of the rationale there.
It's more that like there's that part, yes, but if you're already caching the compiled outputs of example classes,
right,
then creating a jar is relatively inexpensive.
Right.
You don't have to store a duplicate copy of the classes, just with the only difference being them in a zip.
Right. Right.
So it's kind of counterintuitive. But path sensitivity for cacheable tasks basically means that when your repo moves from one folder to another, then the input is taken from the perspective pathing from the project directory. So the project directory is the same, and its path is the same. Then, hey, that's a cacheable task because it has the same fingerprint and it has the same relative path. Versus the absolute path, which may be 2 different directories. It's an annotation.
Ah, that's right.
And this one may not make sense to be a cacheable task for your same point of like, you're taking in a jar. Well, the jar is not cacheable, so then cacheability may not be something that you need to worry about. So we can
this path sensitivity isn't going to do anything unless this is a cacheable task, right?
That is correct.
Okay. This task, I mean, there is some computationally expensive stuff, or that goes on in this task. So it might be worth it to cache this.
Yeah, your input's going to change every time though, so you're going to get a different fingerprint. So in this case, it's always going to execute due to the previous task not being cacheable.
Well, just because the previous task isn't cacheable doesn't mean that its output changes every time, because it could be up to date for other reasons, right? Like if you, even if, so long as you're getting out the same jar in the previous task, this should still be able to cache that, right?
So you're mixing 2 topics. So there's up to date, which has the fingerprints changed.
Yeah.
And then there's the second keyword from cache you
Mm-hmm.
generally see,
Yep. Yep.
which that's actually downloading the
Right.
actual input. Well, if your inputs change, in this case, we're dependent upon the jar task. The
Mm-hmm.
jar task will always execute
Well, the
unless it
chart
hits.
task can be up to date even if it isn't cacheable, right?
Well, in the context of cacheability, the jar task will always execute. In the context of up to dateness, the jar task may not execute. Up to dateness is driven by your inputs, input file, input
Right.
delivery. Cacheability is driven by the cacheable task annotation in conjunction with those inputs. It's an additive,
Right.
like one step
Right.
further.
Sure.
So annotating a task that where its inputs are not also cacheable is kind of counterintuitive because it won't ever get a from cache because the inputs will always change. Because
But
jars usually have timestamps in them,
I
like
don't.
meta enough as an example.
Well, I wonder if we do have timestamps in this one. I mean, I feel like timestamps have often been like avoided putting timestamps in jars and things like that
Mhm.
for exactly that reason. I
Yeah.
wonder if we actually do have like timestamps in any of these jars. But because like if it was up to date and like you've got the fingerprint, the hash of it, I don't see why like when it's time for this Raj task to begin executing, so long if it could tell that the input hasn't changed since the last time it ran, then it should be able to use the same cache entry,
Yeah.
right?
So let's put it a different way. The input wouldn't be in the cache server
But
because
that
the
doesn't
output
matter.
wasn't cached.
But it doesn't need the input to be in the cache server if the input is available locally and has the same hash.
Yeah. So that's if we let me I'll work backwards here. So let's say we
Yeah.
have a clean repo. In this case, we don't have any build folders, nothing's there. When you run the build, it's gonna first check the remote caches for any cacheable task, looking for those inputs that match the checksums of the configuration.
Hmm.
And if those inputs are there, it's going to download them eagerly. Well, not eagerly, but when the tasks are requested, it will download those and use those locally from wherever those files were generated. And then if you were to run that build a second time, the caches wouldn't be used. You would be using your local cache or really your local built artifacts, in which case you'd be getting up to date checks. So if we think about it internally from a process flow, Gradle says, hey, does the local artifact exist? Yes, it's up to date. No, is it a cacheable task? And does the cache entry exist? Yes. Download it? No. Build it. You kind of seeing the process tree here?
Yes, but I don't know if I believe you. I'm skeptical that 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 for any cache hit to happen on a task, all of the tasks before it in the task tag have to be themselves cacheable. I just don't think that sounds like what you're saying, and I don't think that's true.
So any of the tasks that are dependent have to be
Yeah,
cacheable.
I don't think that's true. I think that like
So
if
here's an example. So
yeah,
let's say you've got this jar task that's dependent upon, or Raj task that's dependent upon the jar.
yeah.
Well, if the jar gets rebuilt, it's likely going to have a different fingerprint inherently.
Well, not likely. Let's say it doesn't. Let's say the exact same jar comes out because like there's no timestamp gets put in the meta INF or anywhere else. Exact same jar comes out with the exact same file hash.
Then in theory, it would be able to download that.
Right.
Yes.
Okay.
There's just a little qualifier there. In theory, if you manage to get the exact same checksum
Yeah.
from that remotely cached artifact. Um,
Right.
Now, I think this is where outputs are only cached when the task is cacheable to then go into the inputs of the next tasks. So, like, because jar is not cacheable, then its outputs aren't going to be stored. So
Yeah, well,
then
they're not gonna be stored in the build cache, but they'll be there on your local machine. And the build cache with your cacheable task, it'll store the hashes. It'll store the fingerprints
Yep.
of those inputs.
It would store the fingerprints, but if the output isn't cached, then you're
Then
going
it
to
would
get a
have to be something
caching miss.
that was rebuilt locally. Yeah.
Yeah. So there's a lot of it depends. There's
Yeah, it is very easy to make a task cacheable and then find out that in practice it isn't ever coming from your cache or from a remote cache. And that is a there's an option uh, in Develocity, you know, while we're doing performance tips and tricks. Let's see, rewrite build Gradle plugin. I think we have this in here. Um, Let's see, where was the Develocity configuration? Or do we? I guess we don't actually do the Develocity configuration in this project. We do that just in the
it's,
individual settings.gradle of each of the projects. Oh, wrong one.
yeah, we haven't created a settings plugin yet for that.
Yeah, but yeah, we could, but it's also not that big a deal. Where let's see. So yeah, here it is. So inside of settings.gradle, if you're going to use Gradle build scans, either because you have a Develocity server like this one, which
Mhm.
Gradle set up for us because, you know, OpenRewrite's an open source project and they're cool guys who like to support open source projects. But if you, in the configuration of the build scan, you enable the capturing of these file fingerprints, then you get much more detailed information in a build scan about exactly why a cacheable task was not up to, you know, wasn't able to be resolved from the cache. So
Mhm.
if you are trying to take advantage of remote build caches, uh, definitely enable this setting and look at your build scans to see if any of your tasks are actually coming from the remote cache you have set up. And this is a kind of a differentiator because like the Gradle build caches for Gradle builds can be hosted on Artifactory as well. Like you don't need Develocity to host this build cache, but it helps in my experience enabling a build cache. If you don't have this information, you can turn on your build cache and then benefit from it incredibly minimally without actually going and checking, oh, I actually am getting things from the cache, I actually am taking the artifacts produced on our CI builds.
Yep.
uh, and you know oftentimes that's the way that you notice that you know you don't have path sensitivity relative or what have you. You know, like a cache entry was stored with, well, this path is at, you know, C colon program files whatever, and I'm on a, you know, and can't reuse that on someone's Linux machine or Mac, obviously, you know.
Yep, exactly. Um, the second improvement, and this is, it kind of ends up forking a little bit, but you should never call get project from a task. And the reason is that starts to break configuration cache because projects should be isolated from the tasks. Their configuration should be, you know, provided externally by a plugin. So calling things like get project or um, trying to get the file operations, these kinds of things really should be using the injected services. Or if
Mm-hmm.
you want to reduce your boilerplate even further, you can make your task abstract and then still define your inputs as just
Mm-hmm.
public methods. And Gradle will automatically do a lot of the wiring for you.
Do you have an example of a plugin that follows those best practices, or one that shows a good way of the modern way of authoring Gradle plugins that is configuration cache compatible?
I do not have one right off the top of my head, honestly. Um, not finding one quickly. But I mean, it's just little things that you kind of pick up. It's hard to articulate sometimes.
Yeah, there's a lot of nuance, or
Yeah,
a lot of detail in fiddly edge cases. I don't I don't blame people who just want their builds to work quickly
mm-hmm.
and reliably, and not have to think about it very much, so that you can think
Yeah,
about the software you're actually trying to build with the builds. But there is a niche. Your developer tools, your build tools, your IDEs inflict inefficiency on all of your, you
yeah,
know, on yourself and all of your peers. I got into developer tools originally because the build was a source of complaints for people, and at Tableau, where I worked at the time, and when I'd go and make something about the build better, initially Ant and Ivy and then later Gradle, my coworkers would be so happy, like, oh, thank you, that was a thorn in my side,
mm-hmm.
that took forever and now it's fast, that worked half the time and now it works all the time. And that doesn't that would make more of a difference to my actual colleagues than finishing some ticket for a customer.
Mm-hmm.
So I found that to be very rewarding.
Yeah. If you ever debugged a Gradle build, anytime you see those like underscore decorated
Mm-hmm.
extensions on the class name,
Mm-hmm.
that's where Gradle has extended your class.
Mm-hmm.
And it does so that it can add a bunch of its own hooks into extensions and classes and properties. But
Mm-hmm.
those extension points ultimately do give things like, in your case of your provider regular file, it would go
Mm-hmm.
ahead and create the get objects dot file property for you without
Mm-hmm.
you actually having to write that code,
Mm-hmm.
which can be useful.
Absolutely. Absolutely.
Reduce
All right.
boilerplate.
Yeah, reduce the boilerplate. All right. Well, we've talked about Gradle build performance for about an hour. Any final thoughts or remarks, Shannon?
There's the Gradle best practices open rewrite issue, which helps guide teams or users who want to get involved in
Hmm.
some of those best practice recipes that don't exist yet. But
That's true.
maybe
We could
kind of focus.
definitely have more of those.
This would be a
Absolutely.
great place for people to get started to say, hey, let's add one, that's impacting them.
Yeah, like that old and unholy way of dryly doing dependency version stuff with the that you noticed that I added support for upgrade dependency version to yesterday. We should definitely add a Gradle best practice to move builds away from that way of doing dependency versions, since, as you pointed out, it truly does not work on newer versions of Gradle. Uh,
Yeah, that'd be
Yeah.
one.
yeah, that would be one. That would be one to add to the list. Well, all right,
And
Shannon.
we're
Thanks for. Oh, go ahead, Tim. Sorry.
yeah we're adding like a first look skeleton recipe to do exactly that. And kind of like have a way for folks to add to the best practices that we cover. So we
Mm-hmm.
already have the one that Jente contributed quite a long time ago to do
Mm-hmm.
silly things like this one. Move from
Mm-hmm.
that, I think now deprecated map of
I don't
defining
know
these
if it's
things.
deprecated, but it doesn't feel. Well, I mean, the style tends to be the string notation over the map notation.
So
I think
there's a
it's
LinkedIn post that was posted by one of the Gradle people recently.
Oh, has it
That
recently been deprecated?
they didn't. They said it will be soon deprecated. Is the
Okay,
specific
so
wording,
it's pre-deprecated. Got it.
but as part of the best practice, it was, hey, use string notation. It's
Yeah,
cleaner.
Every,
It's easier.
everyone understands it.
Yeah.
yeah.
Putting the words group, name, and version 5,000 times in your build file isn't doing anything for anybody. Just use the string notation.
Yeah.
Yeah.
Yeah, so we have this one, and then we even found one in our own code. So fix it just the other just before the call. So this one is now not using that anymore. So if you want
Nice.
to add more to it, then of course, yeah, have a look at that issue that we linked. It's in the chat as well, and then hope to see some more engagement there for like any of the other major topics that they want us to do things better. Which I think going into Gradle 9 with some first release candidates, I think you definitely want to be using those best practices. Yeah. So that should be interesting.
Absolutely. Well, all right. Thanks for joining us today, Shannon. Thanks for everyone who watched. Hope you found this interesting, educational, or at least don't regret it. And
And
I'll
then with
see.
that,
Oh, go ahead, Tim. Sorry.
yeah, then with that, thanks all for joining us. And then next week we have a special edition with Kevin Carpenter on the call, showing how we've been able to scale up the platform to now handle 3 billion lines of code. So that should be an interesting one.
A lot of lines of code.
Hope to see you all there. So,
Yeah, I look forward to it.
Yeah, for sure.
Thanks, everyone. Bye.
Yeah, thanks. See you.